Welcome to EDU World Space.
In this problem, we're told that John is pushing his daughter in a wheelbarrow. The wheelbarrow then hits a brick and basically causes it to stop. And we want to know how much force John needs to apply along the handle of the wheelbarrow so that the wheelbarrow just starts to climb over the brick. So we're given that the angle between the handles and the horizontal is 15 degrees. The weight of Rachel and the wheelbarrow acting on the wheel is 400 newtons. The wheel has a radius of 20 centimeters and the brick has a height of 8 centimeters. So we need to kind of look at a couple of things here. I made a free body or force body diagram of the wheelbarrow and then also one for the wheel. So on the wheelbarrow we have the force acting down onto the wheel, a force from the wheel, the components here from the wheel on the wheelbarrow, and then the force from John pushing the wheelbarrow. We also have the diagram on the wheel shows that we have a force vector here from the brick and the force vector here that equal and opposite to these on the center of the wheel from the wheelbarrow. Now, because the wheel is just leaving the ground to roll over the brick, the force between the wheel and the ground is 0. So we've lost contact here, so this is 0. Now, what I did is I first took a moment about this point here where the brick hits the wheel. And I defined an angle, this angle here as alpha, the angle between this radius, this moment arm vector and the horizontal. So we take moments about this, we see that the moment caused by this force here is FYR cosine of alpha, because this here is the moment arm. That's cosine of r cosine alpha, and that's positive because it's in the I've defined counterclockwise to be positive, and f of x produces a negative moment or a clockwise moment as drawn that has a moment arm of r sine theta, this distance. And so that all has to be equal to 0. Now we can cancel out an r here. And what we need then is we need alpha, the angle alpha, but we have enough information to figure that out from the geometry, and because we know this right triangle here, we know this distance, the vertical distance is r minus d, the hypotenuse is r, and so sine of alpha equals r minus d over r, and then from that we can get the cosine, because we know the cosine squared equals 1 minus the sine squared. In the end, we're going to need the cotangent of alpha, and so we can take, that's just the cosine over the sine. So again, knowing this geometry, we can figure out what this is. Now, we don't know what these two guys are, but we want to basically then relate them back to what t is. And so now we can take a look at this, the wheelbarrow. And in the vertical direction, we know that f of y needs to offset the weight, and the vertical component of the tension or the force that's John pushing on it, so that's w plus t sine theta. In the horizontal direction, f of x must offset the horizontal component of t, or t cosine theta. And then from down here, we know that f of x prime and f of y prime have to be equal to f of x and f of y, respectively. So the force vector from the brick and the force vector from the wheelbarrow have to cancel each other out for the wheel. So we can take this and plug them into here, and we get that t cosine theta equals w plus t sine theta, all times the cotangent of alpha. And so everything, we know everything in this equation but t, So we can solve for t and plug in values, and we get that t equals 859 newtons. Now we're asked for the angle and the magnitude of this vector here. We could obviously, once we know t, we could obviously plug them back into here and figure out what the components are, because the components of this vector are just the opposite of the components of this vector. And we have everything we need to find the magnitude and the direction. So it turns out the direction is actually the direction it's going to act through the center here. And that direction is actually the angle is alpha again. And it turns out that alpha equals 36.9 degrees. So that the angle from, again, either from the horizontal, between the vector and the horizontal, is alpha, or 36.9 degrees. And then we can figure out the magnitude. Again, we know both the components, so we just square them and sum the squares and take the square root, and that becomes that gives us 1,040 newtons.